Alright, here we're going to look at normal distribution and how we use normal distribution to answer and analyze some questions. So first of all, we have that in 2011, high school seniors had the following mean and standard deviation on the mathematics portion of the SAT exam. Your mean was 514 and your standard deviation is 117. So before we get to any of the questions, we need to come down here. This is called a normal distribution graph. And these graphs are set up in very specific ways. First of all, you can see that it's broken down into your mean, and then on either side of your mean is going to be the number of standard deviations away from it. So in this case, my mean is that 514 number that we were given. Now we also have some important information at the structure on a standard deviation graph. So between your first standard deviations in the positive and in the negative direction. So this first piece right here, this part is going to represent 68% of all of your data values. Okay. Now when we look at it, that's because this individual piece right here is going to represent that 34%. And both of these individual pieces are exactly the same. Okay, so they would be the same percentage of your data points. So as a whole, they represent 68% of your data. Now, in looking at the next piece, we would have between my two standard deviations, so say from here to here, okay, and so these would be between my two standard deviations. Now this entire piece right here is going to represent 95% of your data. So if this middle part represents 68% of the data, then what that actually means is that this leftover piece here and this leftover piece over here on the outside, these two are going to be the exact same in terms of their data, and this is 13.5%. Now that leaves our last but not least set, and that would be this piece way down here. Alright, so this piece way down here is going to represent 99.7%. Well, what that means is that, again, just like before, we've got these little pieces that aren't quite included in the big. So we've got this little piece here, and we have this little piece over here. Okay, so these two pieces on these outer sides are again going to be the same, and this is going to represent 2.35%. Well, what that leaves is it leaves your outer parts. So if going out to 3 standard deviations represents 99.7, then what that means is going all the way out to the ends is going to represent 100%. So these pieces on the end down here, so we're talking this piece down here and over here on this other side here, are going to represent 0.15%. Okay, very small. Now that being said, now that we got it all labeled, we have to go in and we actually have to label what's going on here. So we're told that our standard deviation is 117. So if I'm going to start at my mean and go out to a standard, then this is going to be 514 plus my standard deviation. So in this case, we're going to end up getting that this value is 631. Well, if we go from one standard out to two standards, this is going to be, take that 631 and add another standard. So here we're going to end up with 748. And again, if we go out to my third standard, we're going to get 865. Now notice, on this right hand side we're adding. My standards are going up in a positive. We have to do the left hand side. Notice they're all being subtracted. So if I start at my mean and go out 1, this is going to be 514 minus my standard, which is going to give me 397. If you go down to 2, this is going to be where I just was minus another standard, which is 280. Come down to the bottom and we're going to end up with 163. Once you get it all labeled, then you can go in and answer your questions. So here my first question wants to know the approximate percentage of scores that were greater than 397 but less than 631. So we're looking at 397 to 631, and the percentage of scores that falls in there is going to be 68. So this is 68%. The second one says, what two scores have approximately 95% of the data between them? So looking, my 95% is going to fall between two standards. So this is going to be 280 to 748. Last, we want to describe the best and the worst. So when we're looking down here, this is considered your best, and over on this side is considered the worst. We're talking about the very top and the very bottom. So when we want to describe where that occurs, we would describe it by saying that we are going to be below 163. Whoops, sorry, I mixed those up. This is the exact opposite. Over here is going to be my worst, and on this side is going to be my best. So again, we're going to be below 163 as a score, and we'll be above 865. Okay, so the best and the worst. And for this particular problem, that's all that we're looking for. So the big chunk of the work, as you can see, comes from being able to label and know your normal distribution. All right, let's look at one more here. So we have that 500 freshmen at Anywhere High School took an algebra test. The scores were distributed normally. you've got a mean of 75 and a standard deviation of 7. So here I have a normal distribution curve. So I need to go ahead and label my curve. First thing I would label across the bottom. The center is your mean, then you're going to go plus a standard, you're going to go plus 2 standards, and plus 3 standards. Then you got to subtract. We're going to subtract a standard, subtract 2 standards, subtract 3 standards. My mean was given to me as 75. To get to my first standard, I'm going to have 75 plus my standard of 7, which is going to give me 82. My second standard is going to take my 82 and add 7 to it, which gives me 89. And my third standard is going to be 96. Going the other way, my 75 minus 7 is going to give me a 68. Again, I'm going to take where I was, subtract another standard, which gives me 61. Going down to my third, I have 54. Now the other piece that you need to take a minute and do is you need to go ahead and label your distribution. So let's go ahead and do that real quick. Again, between my first standard deviations is 68%. As reference, each one of these pieces is worth 34%. My next standards are going to be down here around 2. So we're going to be down here. This is going to have 95% of my data. Since both of these center pieces are 34, I need to know what the outer piece is going to be. So this piece right here along with its matching piece over on the other side are each going to represent 13.5%. And then we have, last but not least, our bottom piece. So we have our piece down here on the bottom. We'll go ahead and input that one here. So that is this part right here, which stretches out towards my third. This is going to represent 99.7%. That also means that the little stretch that is going to go from here all the way across down here is going to be 2.35%. And then at the very end we have my best and worst. So this part out here, so this is going to represent my worst, and it's 0.15%, whereas this piece over here is going to represent the best. Okay. So I've got everything labeled. Once you do that, all that needs to happen is you just need to use it as reference to answer your questions. So the first question says, what percent of scores are between 61 and 82? So you're going to come up and you're going to look. I have 61 is going to show up right here at my second standard. And then I have 68 to 75 to 82. So if you look, we're going 68% plus the additional. So in this case, I know my middle is the 68% plus the additional 13.5% is going to give me 81.5% of the scores is going to fall in that section. Now the second part wants to know the percentage between 75 and 82. So if you're looking at 75 to 82, we're looking at just this first piece here. We're going one standard only. So this would be 34%. What percent of scores are between 61 and 89? So 61 is at my -2 standards. 89 is at +2. So when we're looking at the percentage here, that's going to be my green percentage, which is 95%. What percent of scores are less than 61? So here, if you're looking, I have 61 is at my -2. I want less than that, so I have 2.35% plus 0.15% is going to give me 2.5% of my scores. What percentage of scores are greater than 96? So if we're looking here, that percentage is going to be this itty bitty tiny piece, which we know to be 0.15%. Now these last two deal with a little bit of calculation. Approximately how many algebra students scored between 61 and 89? So here we're looking for the number of students. So we want 61 to 89. We're looking at 2 standard deviations, so we're looking at 95% of our students. So we have 500 students, and we're looking at 95% of them. Well, this is the same as 500 students times 0.95, which is going to give me 479 students. Last, approximately how many algebra students scored higher than 89? So 89 is right here at 2 standards. So I have all of my 2 standards and 3 standards and above. So this is for 2.35% and 0.15%, which we already calculated up here to be 2.5%. So again, I'm going to have my 500 students times 2.5%. In this case, that is the same as the 500 times 0.025, which is going to give me 12.5 students. So there you have it. Again, the meat of these problems comes from being able to label this normal distribution. Okay? So if you have any questions about the normal distribution, please let me know. Otherwise, I do hope this video helped to clear up any confusion. And I look forward to seeing you next time.